In this session, we're going to take a look at the steps necessary to draw a Lewis structure for a covalent compound. The first thing necessary is to determine how many valence electrons are available to you. To do so, you must look at the periodic table. And at a quick glance, all you need to take a look at is the actual group number. So first of all, in this compound, methane, CH4, we have hydrogen. We have 4 of them. Hydrogen's in group 1, so each hydrogen brings in 1 valence electron. So you have a total of 4 valence electrons from your H4. Then you have carbon. Carbon's in group 14, and everything in group 14 has 4 valence electrons. So carbon brings in additional 4, so we have a total of 8 electrons to be able to work with. Now in this situation, I'm going to change it up a little bit. Instead of thinking about electrons, we're going to change it to something we can all relate to, and that is money. So we're going to say instead of 8 electrons, we have $8 to be able to spend as we go into our electron store to buy our necessary electrons to build our model. The next step we're going to go through here is we're going to realize or try to figure out who goes central. In this process, the ones that go central will be, there's 3 things you can take a look at. One is who likes to perform the most number of bonds. Another helpful hint could be look at the element with the lowest electronegativity. And the third key third hint or aspect you can take a look at would be just looking at the ratio of the elements within the compound and putting the lowest number in the ratio central. In this situation, we have methane CH4 is 1 carbon to every 4 hydrogens. So carbon goes central. After you figure out who goes central, then you're going to attach everyone to the central atom using single bonds. So you're going to get yourself a skeletal structure. So we have our 4 hydrogens, and we attach them by our single bonds. So the next key thing is keep track of your budget. You always have to, again, monitor how much you spend, and that will actually guide you through the process of developing your structure. At this point in time, you bought 4 single bonds. Now, understand this. Every single bond represents 2 electrons. It's as if 2 electrons have been packaged already for you, so this package costs you $2. When you buy an individual, or when you buy a dot costs $1. And both these are representing electrons. So in this situation, you just bought 4 single bonds, which cost you $8. So you have $0 left in your budget. And that's your goal. You want to make sure you spend all of your money. You can't spend any more, you can't spend any less. It all has to be spent. So in this situation, you've just spent your money. Well, before we walk away and assume this is taken care of, we have to do a double check. So first of all, in doing our double check, we make sure all the elements on the outside are happy and they have what we refer to as a full octet. First of all, taking a look at our hydrogens. Hydrogens fall into a group that are unique, and hydrogens, as we see here, have a single bond. Hydrogens always are in group 1, and everything in group 1 has 1 valence electrons and prefers only 1 bond, doesn't want any lone pairs. Everything in group 2 has 2 valence electrons, it likes 2 bonds and no lone pairs. For right now, all of our transition metals, group 3 through 12, we're going to assume that they have 2 valence electrons, because if you remember back to our electron configuration, they make it through the S block, but they never made it to the P block. So the two electrons in the S block are their valence electrons. We're just going to assume that at this point in time, even though there's always exceptions outside the box. So group 2 and all of our transition metals are going to act the same. They have 2 valence electrons, they only want 2 bonds, they want no lone pairs. Group 13 will act as the same way, and they have 3 valence electrons, they want 3 bonds, they want no lone pairs. Those ones are your exceptions to the rule. And so in this situation, you just want to make sure they have their bonds. You're not making sure they have a full octet shown around them. The full octet shown around the elements comes into play from group 14 on up to your right. So group 14, 15, 16, 17, and 18, those are the ones you have to show full octets with. So in this situation, we see each of our hydrogens, the 4 hydrogens, have single bonds. And so they are all happy. After you look on the external elements and make sure they are happy, then you focus your attention on the central atom. As we see, the central atom carbon has 4 bonds around it, and that's what group carbon wants. Is in group 14, it loves 4 bonds. Or you can count it and you see it has 2, 4, 6, 8 electrons. So everyone's happy. The last thing you need to do before you leave this is not only do you make sure, again, every element has their full octet or they're happy, but then you make sure that you have spent your budget. And so you do a complete count of the whole molecule. And as we see here, we have 4 single bonds, adds up to 8, and we spent our budget, and everyone's happy. So this verifies that this compound or this molecule is drawn out correctly.